everyone, and welcome to a short video on dimensional analysis for nursing specifically. So quick note, my name is Alicia Langdon. I am not a nursing faculty member. I'm actually a mathematics instructor, but the nice thing is to have someone who knows the background of mathematics to help explain these ideas and try to give more logic into what we're doing. So this video is going to talk about some conversions that you should know. It's also going to describe and outline dimensional analysis, talk about what it is, what we're going to do, and then we'll finish up by doing several examples. So make sure you've got your calculator handy and you're ready to do those problems along with me. Maybe get some scratch paper out or notebook and a pencil with an eraser, because mathematics, it's always good to have an eraser handy. So let's jump into this by talking about what is dimensional analysis. So dimensional analysis is one of the three primary methods which exist for calculation of medication dosages. You may be familiar with some of the other ones. So the first one is dimensional analysis. You may have done ratio proportions. This is where you're cross multiplying. That may be familiar with you. And desired over half method. Now those two other methods we're not going to talk about, but I just want to make you aware that there are pros and cons to each method, and some methods are better used for certain areas and some are used for other areas. Dimensional analysis will work for all methods, and it's best used when you need to convert from one unit to another unit. So dimensional analysis is our problem-solving method that uses conversion factors. So things like 2.2 pounds equals 1 kilogram. That's a conversion factor. It's telling you how to convert between the two numbers, or units, excuse me. And it's the fact that any number can be multiplied by 1 without changing its value. So what's happening here is they're saying, if I multiply any number by 1, I'm not going to change that, right? 2 times 1 is 1. So if I have a fraction that is equivalent to 1, so like 5 over 5 would be the same thing as 1, we can multiply that without actually changing our value. So keeping the equivalence as we go through our problem. So if you've ever had chemistry or physics before, you've seen and done dimensional analysis. It's in there. I did it when I was in chemistry class in high school, long time ago, but it's pretty easy to pick up once you've learned this skill. So once you have it down, even if it's been a few years, you can always go back, refresh yourself, and get it back up. That's the beauty of learning things. So conversions, you should know. These are just some of the conversions I wanted you to kind of go through and understand. These are not all the conversions you need to know. Make sure you're talking to your instructor about any other conversions you might need to know. I think the only one, I think we have all of the conversions we need for today's lesson though. So things like 1,000 milliliters equals 1 liter. 3 teaspoons equals 1 tablespoon. 1,000 micrograms equals 1 milligram. So those are in the metric system. I'm not going to be going through the metric system, but if you're still feeling a little uncomfortable on the metric system, I do encourage you guys to go and review that as well. Some other things, 30 milliliters equals 1 ounce. That's especially useful if you like cooking as well, or baking. I love baking. 2.2 pounds equals 1 kilogram. I mentioned that earlier. That one's going to be a big one, especially when we get to the weight problem. So make sure you have that jotted back in the back of your memory. Or if you haven't memorized it yet, note card, put those units on there, have them handy and ready to go. So I may be going back to that site myself just to remember. So I wanted to start with some hints before we get into those word problems. So dimensional analysis can be tricky because oftentimes we have a word problem, and word problems bring out the fear in us. but you can all do them. It's just about picking out the information and knowing what you're looking for. So the first hint is to start with the order. So when you're given the problem, read through it and make sure you identify what is the doctor ordering? What does he want to know? That's going to be the crucial piece of information that you're going to start with, is that order. Find the conversion factor as well. So for example, if you're looking at the drug label and you're reading it and it says, okay, this drug comes in 15 milligrams per milliliter or something like that, that would be your conversion factor. That's not what the order is, that's what the label reads as, it comes in, okay? That would be your conversion factor, aka the supply. Now, the next step is to make sure the units match. And if not, you'll need to convert. So when you're looking with what the order is and what your conversion factor is, the units should match up. So for example, if you have one unit in milliliters and the other in liters, you're going to have to convert that because they're not in the same unit. So we'll have to do a little bit work there. Just make sure you're noting if they are the same units, and if not, we're going to have to do one extra step. Now, once you have your answer, a lot of times it feels really good to go, I got this, I did amazing, go me. But we do want to take that extra moment to double check that we did it correctly. And what I mean by that is let's look at our answer. Let's look at the units that are left over and go, well, do they match what I'm actually looking for? So for example, if I ended with milliliters per hour, I need to go back to my question and go, is that what they were looking for? Is that what they wanted the answer in? So make sure you're always double checking yourself at the end. Because oftentimes if we don't get the correct units, that's a hint to us that maybe we either didn't do it correctly or we didn't take it far enough. We didn't do enough steps. So it's actually a good check for us. So those were our hints. Let's jump into our first practice problem. And the first practice problem is really just a one-step conversion. So this problem says that the doctor ordered 650 milligrams of Tylenol to be given. The supply on hand is 325 milligram tablets. How many tablets would you give? Now, I'm going to preface this with saying I know nothing about drugs. I'm going to be honest there. Don't know a whole lot. So when you're reading these problems, if the numbers seem a little bit off about how much we should be giving the patient, please forgive me. Okay? I'm clearly not a doctor. So let's just follow the doctor's orders and see what we come up with. So the first thing we need to do is figure out the order. So what is the order? It's 650 milligrams of Tylenol. That's what we always want to start with, the order, 650 milligrams. Now, we want to turn this into a fraction. It's not currently a fraction, so how do we turn it into a fraction? Well, we can just put it over 1. And in fact, you can do this for any number whatsoever. Just put it over 1, boom, you got a fraction. End of story. Now, the next thing we need to do is look for the conversion factor, or what the supply we have on hand is. So the supply on hand is going to be 325 milligram tablets. That means for every tablet, every one tablet, it's going to be 325 milligrams of that medication. So what we need to do is we need to turn that into a fraction. So 325 milligrams per tablet. That's going to turn into a fraction, 325 milligrams over one tablet, because every one tablet has that much medication. Or we could, in fact, flip that and have the milligrams on the bottom and the tabs on the top. So how do we decide which goes on bottom and which goes on top? Well, the idea is that the units need to cancel. So they need to occur diagonally. Okay, diagonally. So since the milligrams is on the top, that means the milligrams in our conversion unit need to go on the bottom. So let's go ahead and write that on the bottom. And then we'll put the 1 tab on top. So what happens is that we get these units, these milligrams, to cancel, and we're simply left with tablets, which is what we want for our answer. See, the answer says, how many tablets would you give? Well, we ended with tablets, so we're on the right path. We just have to do one more step. And that one more step is that we need to multiply across the top and across the bottom. So across the top, 650 times 1 is just 650. And we're going to bring over our units, if there's any units left over, 650 tablets. 1 times 325 is just 325. The units canceled, so there's no more units there. Now we just need to take the top number and divide it by the bottom. So 650 divided by 325 is 2. We need to give our patient 2 tablets. And to me, that goes, okay, that makes sense. I feel like I'm not overdrugging my patient because I'm not giving them like 50 pills. That would probably be a bad thing. Okay, I will not do that. So it's good to just double check your number. Does it make sense? Are the units matching? Yes and yes, I'm good to go. We can move on and try our next problem. Apparently I had 2 slides of that. We'll ignore that. Okay, we're going to move on to 2-step conversions. Oh no, 2 steps. That just means we need to convert one more time. So the doctor orders 2,000 micrograms of Smartella. That's not actually a medication. It's just something that another person came up with that I thought was pretty funny. Every 8 hours by IV. In the medical room, you see that Smartella comes in vials that have 4 milligrams of drugs per milliliter. How much Smartella do you need to drop? Let's start with what we always start with, which is our order. So our order is 2,000 milligrams of Smartella. I ignore this every 8 hours because every 8 hours you'll be giving the same dosage. Doesn't matter how often you're doing it. Ignore extraneous information. Don't need to know that. Boom, cross it off, ignore it. So we start with our order, which is 2,000 micrograms. Okay, we're going to make that a fraction by putting it over 1. Now we need to see what we have as for our supply. So it looks like we have a supply, a vial that has 4 milligrams of drug per milliliter. So 4 milligrams per milliliter. When there's no number in front of that units, we assume it's a 1. So it'd be 4 milligrams per every 1 milliliter. Now that's our conversion unit. Remember that you can switch the order. Write milliliters on top, milligrams on bottom. We just have to see how it matches up. Remember, we want it to match up diagonally. Well, if we look at the units that are currently on the top, we see that it has micrograms. What's the problem? Micrograms does not match either one right now. So we can convert it, and in fact we can convert it to milligrams by using our handy dandy conversion unit of 1,000 micrograms equals 1 milligram. And this was on the conversion units you should know at the very beginning, just in case you're wondering where I got that from. Okay, so now look at the units cancel. Micrograms, micrograms, bye-bye. Now we have milligrams, which we can match up. So we're going to go ahead and match that up diagonally and put the 4 milligrams on the bottom and the 1 milliliter on top. Recall that this is our conversion unit. It's our supply. It's what the drug we have is. So again, we go ahead and cross off those milligrams, and we notice that our answer, what we have left over, is milliliters. So do we want our answer in milliliters? Should we be giving it in milliliters? Yes, it's in an IV, so we should be giving it in milliliters. That would be weird if we didn't have a liter or milliliter answer. We want it in liquid form, so that'd be weird if anything else. So again, multiply across the top. 2,000 times 1 times 1 is 2,000, and our units are milliliters. Please be extra careful when you're writing your units out, because if we miss a unit, it can be catastrophic, and we don't want that, right? Just remember to cross off the units that are diagonally and keep what's left over. Now on the bottom you have 1 times 1,000 times 4, which is 4,000. And there's no units, so I simply have to divide. 2,000 divided by 4,000 is going to be 0.5 milliliters. And so go ahead and double check that you get the same thing. You know, if you want to pause the video, work through it, you can do that as well. I always encourage you to try it on your own to see if you're getting the same thing that I am. So our answer is 0.5 milliliters, so half of a milliliter, which seems reasonable. Okay, we're not drugging them up too much. It's always a good thing. So you see here we had to take that extra conversion step because we had to convert from one unit to a different unit. So micrograms to milligrams. We had to change that prefix for our gram. Let's do another example where we're doing a two-step conversion and walk through it. So the doctor orders 60 milligrams of awesome sauce, IV. I want some awesome sauce, IV. That sounds amazing. Every 8 hours. Great. I'm not going to care about that. That's extraneous information. Don't care. So I'm just going to cross it off. Don't need to worry about it. Great. Now the vials of awesome sauce read that they contain 1 gram of drug in 10 milliliters of solution. So 1 gram in 10 milliliters of solution. How much awesome sauce do you need to draw up? So again, we got to start with that order. That order is 60 milligrams of awesome sauce. That's just kind of fun to say. Now we're going to turn that into a fraction like we've done before. 60 milligrams over 1. Sweet. Now we need to come up with our conversion factor. So what is our supply? What do we have on hand for this drug? Well, it looks like our supply is 1 gram of drug in 10 milliliters. So 1 gram in 10 milliliters, that's our conversion unit again. Remember that we could always go ahead and just switch that. Boom. If we needed to, which we will, but we don't want to get ahead of ourselves here. So let's go ahead and see if it matches up. So remember, we need opposite diagonally. We need to have these units diagonally. Cancel. So we need to have milligrams on the bottom, but we see right now neither one of these are milligrams. One's grams, one's milliliters. But is there a way to easily convert from milligrams to grams? What's that conversion unit? Milligrams to grams. Hopefully you all said 1,000 milligrams equals 1 gram. That's a common conversion, so the more you practice with it, the faster you'll get. So if you didn't get that right now, just keep practicing those problems and you'll use it so much, you'll be dreaming about it tonight, okay? So milligrams cancel. Now I have grams on top, which means I need to put grams on bottom to cancel. So I am going to flip this unit. So 1 gram goes on bottom and 10 milliliters go on top. Cancel those units that I don't want anymore. And it looks like right now I'm ending in an answer of milliliters. So my question is that what I want to end up with? Do I want to end up with milliliters? Yeah, I'm doing an IV, so I want to end up with how many milliliters do I have to give my patient. So that seems reasonable. So again, let's just multiply across the top, across the bottom. So 60 times 1 times 10 is 600 milliliters. On the bottom, 1 times 1,000 times 1 is 1,000. And there's no units. We cancel them all on the bottom, so we don't have to worry about that. So it looks like this is going to be 0.6 milliliters for our answer. Does that seem reasonable? I think it does. Okay, 0.6 milliliters we're going to give this patient of awesome sauce IV. Okay, we are moving right along. We've got our one-step conversions done, two-step conversions. I'll say most of your practice, what you should practice on are those one-step conversions, and then practice with those units to convert between in the two-step. Okay, so now let's go ahead and do some weight-based calculations. So these are where they're going to give you some weight and you're going to have to use it to make some calculations. So depending on how heavy you are, you may need more medication or less medication. Obviously, I'm going to have to take more medication than a small little baby. Okay. I weigh just a tad bit more, just a tad bit more. So you have a baby, oh, so cute, which weighs 4 kilograms. The doctor orders you to administer 1.4 milligrams per kilogram. So now they're giving you how much medicine per 1 kilogram. Brainsy every 12 hours via IV. Now remember, we could care less about this 12 hours via IV. Great, who cares? Let's move on with our life. So Brainsy comes in a 10 milliliter vial that contains 100 milligrams of the good stuff. Now, how many milliliters of Brainsy should you administer to the baby? Note that Brainsy is not a real drug. Wouldn't it be lovely if we could just inject things and make us smarter without having negative consequences? That'd be fabulous. Super fabulous. Anyways, let's get to our order because that's what we always need to start with. So what's our order here? What do we need to write first? It looks like our order is 1.4 milligrams per kilogram of Brainsy. So order is 1.4 milligrams per kilogram. So we write that first. Per 1 kilogram. Notice I put a 1 in here in front of the kilogram. That's simply as a placeholder. You can, you don't have to put it there. It doesn't really matter, to be honest. Now, what do we know next? Actually, what we usually do next is write our conversion factor, but since we have the weight in here, I'd like to write the weight next. So if you're given a weight, and it depends on a weight, let's actually write that next. So here it says that we have a 4 kilogram baby. Now, of course, we need to cancel our units diagonally. So we're going to write the 4 kilograms on top because that will do a nice job of canceling there. Bye-bye kilograms. Now we can move on to our supply. How much do we have on hand? So if you want to, you can make a little note saying this was our order, this was the weight, and here we're going to go ahead and use our conversion factor as long as the units match up. Conversion factor, or you can think of this as our supply. As long as the units match up, we can cancel it. So 10 milliliter vial that contains 100 milligrams. So this would be like the conversion unit. 10 milliliters over 100 milligrams, and then we could switch it if we need to. Flip it. Let's see if we need to though. So on top, we currently have the units milligrams on top. Remember that you do need to have it diagonally, even though this is a long diagonal. Go ahead and write the milligrams on the bottom and the 10 milliliters on top. So again, the milligrams cancel. One's on top, one's on bottom. Boom. And currently we're left with milliliters. Now, is that where we want to end? Do we want to end with milliliters? Look for my final question. You bet we do want to end up with milliliters. So we're going to go ahead and leave it there. And then we can just multiply across the top, across the bottom, and see where we end up. 1.4 times 4 times 10 is 56 milliliters. Notice I'm bringing that unit along. Good practice. 1 times 1 times 100. Don't need the calculator for that one. It's 100. And there's no units because they all canceled, which is great because we want our answer in milliliters. So the final step is to divide. So this is going to be 0.56 milliliters. That's how much you're going to give this baby. Okay? Keep that baby safe. Know your dimensional analysis. Okay, so that was with our weight-based calculations. I wanted to make a quick note because sometimes I get this question, which is, what if I had put the 4 kilograms first and then the order second? So if I had switched the location of the weight and the order, if I had changed that order, it's not going to matter. You can switch what you're multiplying in which order, whichever way you want to, as long as the units cancel. That's the key. The units have to cancel diagonally. And you have to end with the units that you want. That's your double check that you did it correctly. But you could have done the weight first and the order second. That's fine. It's really what you're comfortable with and what you're used to doing. Okay, who's ready for another weight-based calculation? Because you just had so much darn fun on the last one. Let's do it again. Now, your patient weighs 283 pounds. Obviously not talking about a baby anymore. And just had a BKA. So you do not want him to get out of bed. You go to the med room to get some calm down medicine. Fabulous medicine. And see that it comes in a dosage of 1 milligram per 10 milliliter bag. If you know you need to give your patient 2 micrograms per kilogram of calm down every 2 hours per agitation, obviously I don't care about that because I just care about how much dosage I should give him every time. How many milliliters should you give your patient? A lot going on here. I do see that I have a weight calculation, so I know I will have to put my weight second. So if you want to, you could write down your weight, but I always want to start with the order. Now, as you read through this problem, what is our order? Give you a second to look at that. Now, we're used to simply going to the first sentence and saying, oh, that's my order, that's what I write first. However, here, the first sentence is weight, so we ignore that. But the next sentence is the supply. The med room, when you go to the med room, you see that the supply comes in a dosage of 1 milligram per 10 milliliter. That is your conversion unit. 1 milligram per 10 milliliters, or it might be switched, we'll see. But that's going to be your supply. We need to know what our order is. Our order is what we're giving to the patient. So if you know you need to give your patient 2 micrograms per kilogram, that is our order. So let's write that first. And if you hadn't found that first, which it comes with practice, the more practice you see, the faster you'll see it. The more practice you do, the faster you'll see it. But there's a good double check for this. And the double check is if you had gone through the problem and done the supply first and the order second, what would have happened is the units you had at the end wouldn't have matched up. So it would have been a double check that maybe I didn't do something correctly. So make sure you're always double checking those units at the end. Okay, so here is our wonderful order. This is what I need to give my patient. 2 micrograms per 1 kilogram. I'm going to go ahead and write my weight second. But there is a problem. What's the problem? The problem is that the units do not match. Kilogram and pounds. They do not match. So I need to go ahead and convert kilograms to pounds. Now you could just quickly convert pounds, the 283 pounds to kilograms if you want to and put it in there. but I'm going to go ahead and show you how to use that unit conversion if you ever need it. So 1 kilogram is equal to 2.2 pounds. And if you need to, you can always go back to the conversions you need to know. Double check 2.2 pounds equals 1 kilogram. Sweet. Got it correctly. This is where that note card could be really handy here. And then we say, okay, well, we know that the kilograms cancel. And now I can go ahead and write my pounds on top, 283 pounds. Wow, that does not look like a number. 283 pounds per one patient, or we just put it over 1, okay? 1. Notice that the pounds cancel again. Boom, boom. Great. So right now we have micrograms, which is not the answer we're looking for, because the answer needs to be in milliliters. So we have some more conversions to do. I'm not done yet. Let's keep going. So that was our weight that we multiplied by. Now we need to go ahead and multiply by our conversion, which is our supply, which we have 1 milligram every 10 milliliters. Do these match up to our current units? Our current units are the ones that haven't been crossed off, which is micrograms. Well, micrograms and milligrams are not quite the same, right? In fact, we need to convert from micrograms to milligrams before we can use that unit conversion. So we know that there are 1,000 micrograms in every 1 milligram. Sweet. And then we do some crossing out. Micrograms, bye-bye. See you later. It was nice knowing you. Now we are left with milligrams, which we need to multiply by our supply, because we haven't done that yet, right? We have our order, we have our weight. We still have to multiply by our supply, which is 1 milligram over 10 milliliters. Now I need to flip that because I need my milligrams to go on the bottom to cancel, and the 10 milliliters go on top. What's a good note, and how do you know that you are at the end and you have multiplied everything in there that you need to? Boom! Look at what's left over. What are the units that are left over? Milliliters. What do we need our answer in? Milliliters. Boom! Just got to multiply across the top and across the bottom, and then I am done. You are done. Boom. Well, with this problem. We still have a couple more problems, but, you know, just go with it. 2 times 1 times 283 times 1 times 10 is 5,660 milliliters. Bringing those units along. On the bottom, we have 2.2 times 1,000. You can basically ignore the ones. They're just placeholders. If you multiply by them, it's not going to do anything. So then divide 5,660 divided by 2,200 is going to be 2.57 milliliters. Now make sure you talk to your instructor about how far she wants you to round. I believe it's to the 10th position, the 10th place, which is the first number after the decimal. So if you do the calculation, you'll see that you get 2.572727, blah, 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 blah. Obviously, we don't want to write that all out. So let's round it to the first place. Now, just as a reminder, you round up if the next digit is 5 or higher, or you'll leave it as is and just drop off that next number if it's below 5. So since 7 is larger than 5, you would have 2.6 milliliters. We would round up that 5 to a 6. Boom. Okay. So you are giving our patient 2.6 milliliters every 2 hours per agitation. So Patient, you are annoying me. Here, take some calm down medicine. You will feel better. Okay. Let's go ahead and keep going. So we got our weight-based calculations. We've got our basic calculations done. What do we have left? We have some more weight-based calculations, but we need to do it by time. Now, these ones are a little bit different because the order is going to look a little bit strange. So again, we have a weight problem. We're told our patient weighs 25 kilograms. Great. That's our weight. We're going to pay attention to that. And is ordered, that always tells me that should come first, to be given Squeeze-A-Lot at 2 micrograms per kilogram per minute. That can be a little confusing, so we'll come back to that. Then titrate by 0.1 micrograms per kilogram per minute to target SPB greater than 130. We're going to ignore all this. I don't care about this. Great, ignore. I just care about the order, the supply, and then the weight for weight problems, and then any conversions I need to do to get between them. Now on your bag, you see that Squeeze-A-Lot delivers 250 milligrams of drug in 250 milliliters. That sounds an awful lot like a supply. Better make a note of that. Okay. Now, if your pump runs on milliliters per hour, how much should you be giving your patient? Okay, so this is a little bit different because so our answer should have milliliters on top and hours on bottom. So we're actually going to have 2 units left over. That's a little different than what we've had before. So let's start with the order. This is what we always start with. Let's just keep that habit going. So what's ordered? The order is that 2 micrograms per kilogram per minute. How do we write that up? Well, 2 micrograms goes on top, and then both units that are behind the division will go on bottom. So you're going to have kilograms on bottom and minutes on bottom. And you can throw a 1 in front of there. You don't have to. It's up to you. Just keep in mind every unit after that division bar, okay, to the right of the division bar, has to go underneath the fraction. So you have micrograms divided by kilograms, and it's also divided by minutes. Yay! Now we can go ahead and grab our weight. So this is our order, right? Let's grab our weight. Now, do we need to convert our weight, or is it good to go? Well, it's 25 kilograms. Seems like it matches up. In fact, I can go ahead and cancel those kilograms. Wahoo! My weight is taken care of, and I don't have to do any conversions because it's in kilograms. The order is in kilograms. My life is beautiful and easy. There we go. Now, what comes next? Our supply. We need to come up with our supply. Just hanging out right here, 250 milligrams of drug in 250 milliliters. So it's going to look like this. Or, of course, we could flip-flop it. We have to decide which one we should put, where we should put the units. So they should be canceling diagonally. Now, we are currently with micrograms. Is this a problem? And if so, how do we solve it? Starting with micrograms, we need to change it to milligrams. Got to get those units the same prefix. Got to get them the same. So micrograms, there's 1,000 micrograms in every 1 milligram. Wahoo. Cross out those units. I love crossing them out. Get rid of that messy detail. You don't need it anyways. Okay. Now that we've converted to milligrams, we can go ahead and use our supply, our conversion factor for supply, which is Now, we can't put 250 milligrams on top because then they won't cancel. They're on the same level. So we need to put it on the bottom. And we'll put 250 milliliters on top. Now, what are the units we're left with? I always like to do this after I enter my supply to make sure that I'm on the right track. I've got everything I need in there and double check if I'm missing anything. Milliliters is on top, right? And on bottom, notice we have minutes. Is that what we want? Do we want milliliters per minute? Well, if we go back to that question, that's not what we want. We want milliliters per hour. So we have to do one more conversion here. We have to take those minutes and change them into hours. So the easiest way to do that is just on the end, let's throw on another conversion factor. Let's do it. So minutes goes on top because of course they need to cancel, right? We don't want minutes, so we need to change that to hours. So how many minutes in an hour? Well, it's going to be 60 minutes in 1 hour. Notice the minutes cancel. One's on top, one's on bottom. They're diagonal. And what we have left is milliliters on top, hours on bottom. Did we do it correctly? Boom. Got it. Done and done. Okay, so multiply across the top. Grab your yield calculator. Do some multiplying. 2 times 25 times 250 times 60. Oh, that's a nice big number. 750,000. Oh, I can fit it. Yes. Got to fit those units in. That's what really matters. Tells me if I'm doing things correctly or not. So on the bottom, multiply across 1,000 times 250. 250,000 hours. Don't worry, we still have to divide them, okay? That would be a lot of hours, and I would not be happy. 250,000. Double check your zeros, right? If we don't type in the zeros correctly, that's going to be an issue. So when we divide these, it's going to be 3 milliliters per hour. And of course, we love those units. We double check those units. And does it seem reasonable that we're giving this patient 3 milliliters every hour? I'd say that sounds reasonable. If I was getting something like 700 milliliters per hour, I might be a little concerned that I was overdrugging them, right? Just a wee bit concerned. So let's not do that. Okay. Now we've got weight-based calculations done. Now we can move on to the final problem. Just kidding. Not quite yet. Because I knew you wanted more practice for that. You're like, Alicia, can we just have one more practice problem? Because that's what I really want in my life. And I, of course, going to give it to you because I don't want to disappoint you. So, your order is for a continuous infusion meant to keep intubated, let's just say patients calm. Well, that's interesting. Let's just say let's keep some patients calm. Great, that sounds wonderful. It reads that we need to give them 3 micrograms per kilogram per minute. Okay. Now, of course, we check to see what our supply is, and our supply says it's provided in 1,000 milligrams in a 250 milliliter IV bag. If your patient weighs 180 kilograms, what do you need to give the patient in milliliters per hour, since this is an IV? Well, let's see. So, of course, we need to start with our order. You guys know that. You've got it down. You're like machines now. Our order is 3 micrograms per kilogram per minute. So our 3 micrograms goes on top. Then on bottom, our other units that are underneath those division go on bottom. Kilograms per minute. Both are on bottom. Remember, you can throw 1 in there if it makes you happy. If you could care less about the 1, you don't have to put it in there. That's our order. Of course, we need to multiply it by our weight. We like to put our weight second. Now, what's our weight here? Looks like our weight is 180 kilograms. Pretty decent weight there. Now, I should have done this before I wrote it down, but do our units cancel? Did I need to convert that kilograms to pounds? No. Since our order has kilograms in it, we can just cancel that right off the bat. We don't have to worry about that. Great, bye-bye. Now we have micrograms and minutes left. So now let's go ahead and talk about our supply. What's our supply going to be? Well, it tells us that our IV bag comes in 1,000 milligrams for every 250 milliliter IV bag. So do we keep it that way? Do we need to flip it? Do we need to put in a conversion factor? What do we need to do next? What do you think? You can go ahead and talk to me. It's totally fine. Totally normal. Your family won't judge you. It's totally fine. So micrograms is what we have right now, but of course we don't have micrograms in our supply, so we need to do some conversion. What is that conversion that we need to do? 1,000 micrograms is 1 milligram. It's like our favorite conversion. We just keep on using it until it's stuck in our brain and we're never going to forget it. Once we get that conversion, notice the micrograms fall away. Now we have milligrams. Great. It matches with our supply, which we can go ahead and throw in there. Now, of course, this needs to be flipped because milligrams need to cancel diagonally. And milliliters will be on top. Boom, boom, shakalaka. So we have milliliters on top, minutes on bottom. Are we done? Did we just finish the problem? Not quite yet, because our answer needs to be in milliliters per hour. So we've got the top unit correct, but those minutes need to be changed. So we're going to use that conversion factor of 60 minutes for every 1 hour. Cancel some lovely things. Let's get rid of those minutes. We didn't need them anyways because we wanted the bottom to be in hours. Multiply across the top, across the bottom, and then we can divide away. So 3 times 180 times 250 times 60. Oh my gosh, these are some big numbers. 8,100,000. Boom, boom, boom. And of course I'm going to write my units up there because you know me. Got to have my units, got to stay organized or else chaos breaks out. We don't want that. So 1,000 times 1,000 times a bunch of ones is going to get you 1,000,000 hours. And the easiest thing to do is just cancel your zeros because nobody likes zeros. So it would be 81 divided by 10. Or you could write the whole thing in your calculator. Either way is fine. I just don't like dealing with all those zeros. So 81 divided by 10 is a much easier problem. So 8.1 milliliters per hour. Can't forget both units. They're both there. Got to keep track of both of them. 8.1 milliliters per hour. Okay. Got to keep them calm. Got to do what you got to do. Okay. Now I have 2 flow rate problems. Just checking before I move on. Which is our finally our last problems that we're going to talk about. So flow rate problems are a little bit different, but pretty much the same idea that we've been doing. You have an order, okay? You have a supply, and you have a drip factor. The drip factor is something new, and it tells you how fast the drug is being given. So our answer is actually in drops per minute. So that's kind of the different idea here. So we're not going to take into consideration weight, so we don't have to worry about that. Yay. So let's start with our order. So a doctor orders 2 milligrams of drug to be given continuously every hour. Now, this is where we need to be concerned about the time. So 2 milligrams every hour or per hour. So that's going to be our order, 2 milligrams per 1 hour. So every hour, you're giving them 2 milligrams. That is our order. Now, our second thing is our supply. So our supply or concentration is 500 micrograms per 50 milliliters. Now that is our supply. How are we going to write it? Where are the units going to go? Well, right now we have milligrams on top, but we're working with micrograms. So we need to convert 1 milligram to 1,000 micrograms. Okay, cancel those units, get rid of them. We want to keep it clean and tidy. And now that we have it in micrograms, we can go ahead and use our supply or our concentration. So of course we need to put those micrograms on the bottom so that they cancel. Milliliters is on top. Okay, now we have milliliters on top, and on the bottom we have hours, which not the correct units we want to end in. So we have one more extra unit that we have to multiply by, conversion factor, and that's the drip factor, which is something a little bit different that we haven't used before, but it's going to follow the same rules as before. The drip factor is 10 drips per 1 milliliter. So of course we need to cancel this, so how are we going to write this as a fraction? On top is milliliters, so that means the milliliter needs to go on the bottom so that they cancel. 1 milliliter, and then on the top you have 10 drops. So 10 drops per 1 milliliter. Cancel your milliliters. Hey, we have drops on top. Awesome, because I want my answer to be in drops per minute. So we've got the drops part down, but we still need to convert that hour to minute. We've done this before. The only difference is the hours now need to go on top because they need to cancel, and then the 60 minutes will go on bottom. So drops are on top, minutes are on bottom. Yay, we did something correct because we got the right units. Now multiply across the top, across the bottom. Almost threw my pen there. Don't do that. 2,000. 50, 10. Okay, that is a lot of zeros. 1 million. 1, 2, 3, 4, 5, 6. And that is drops. And then on the bottom, again, we need to multiply 500 times 60, which is 30,000 minutes. And again, we can just cancel the zeros. So you have 100 divided by 3, which is 33.3 drops per minute. It's really 33.33333333. What they like to do is they like to round it to the whole number for drops, because obviously I don't even know how you would do 1/3 drop. How would you even measure that out? So since the next number is lower than 5, we're just going to keep it. So we're just going to drop it off. So it's going to be 33 drops per minute. Wahoo! So again, as we talked about before, with flow rate problems, make sure you're paying attention to how much medication per how much time, and then include the drip factor in there. So 10 drops per milliliter, or however many drops the problem says, 15 30, whatever it is. So let's do one more problem. So a doctor orders 0.4 liters of D5W in normal saline, to infuse over 3 hours. How would you set an IV with a drip factor of 10 drops per milliliter to achieve drops per minute? So we're going to start with our order. Our order is 0.4 liters over 3 hours. So it's literally going to be 0.4 liters over 3 hours. Boom, that's our order. Okay, that's our order. Now we need to multiply it by, now there's no supply given here. And the reason for that is it's apparently just given in this supply form. Okay, so we don't need to worry about that, apparently, for this problem. This is an easier problem than we normally have to work with. Yay! Take the easy ones when you can work with it. So now we need to multiply by the drip factor. And the drip factor is 10 drops per milliliter. Now, right now we have liters on top. That's not going to work for us because we need to get milliliters. So let's say 1 liter is 1,000 milliliters. It is. It's one of the conversion factors you should know. I don't know why I said let's assume. It is. So now we have milliliters on top. So we can go ahead and multiply by our drip factor. Okay, milliliters need to go on the bottom. Great. And our 10 drops will go on top. So the milliliters cancel and we have drops on the top and hours on the bottom. Is that what we want? No, it is not. We want drops per minute. So we need to go ahead and change our hours to minutes. So every 1 hour is 60 minutes. Cross that out. Looks like we have drops per minute. Great. Multiply across the top. 0.4 times 1,000 times 10. 4,000 drops. The bottom 3 times 60 is going to be 180 minutes. Okay. Divide 4,000 divided by 180. Now I got 22.222222. We want to round that to the next whole number, which is 22. Okay. So the 2 falls off because it's not larger than 5, and we just have 22 drops per minute. Boom. Okay. So that was our flow rate problems. Notice that some pieces do not have certain information, and then other problems have more information than you even need to use. So it's really about practicing those skills. And I say this in my math classes. I say this in all of my workout classes. The more you practice, the better you will get. Doesn't matter what you're doing. It could be baking a pie or making the bed. I don't care. The more you practice, the more you do something, the better you get. So what I've done is in the comments section below is I have linked to a couple different websites in which you can practice these skills a little bit more. So go ahead and check that out. Practice, practice, practice. And remember, if you're struggling, reach out for that help. Ask those questions of, I'm not sure if this is the right way. It's a little bit different than the way maybe Alicia, taught it. Is it the same thing? Because a lot of times in mathematics, they're the same method, just slightly expressed differently. But they get you the same result and you've done it correctly. So I hope this video has been a little bit helpful and is getting you on the right path. Practice some more, and I wish you all the best in your future nursing classes. Bye, everyone.